So let's start with the side that says one sample, Z for means. All right, so what I have typed on here is requirements or your conditions, whichever way you want to call them. So this goes back to when we very first started with the very first thing we had. So our conditions at that point were always what three things? Random, normal, independent. So, and we're kind of shorthanding some of these. First requirement is random. The main thing is you determining whether it is random what or what. And so that's all I need you to write for that. So our second condition, normal, way back to when we started, how many possible ways are there to check for normal if I am dealing with means?
Stated.
So there are three. There's stated. Stated what?
Well, you can use the whole constitution.
It's actually stated it's what is normal. What's my other relatively easy way? I am okay if you write CLT on this test because you're not gonna have that much room. But I do want something written beside of this, which is what? Which is which in? And then number 3, histogram of what? Of values. And what things do I check for it? No strong skew. No extreme outliers. What's my third condition? Which is actually and what is my equation for that? Which is same thing. I don't know why I usually write that way. Capital N is greater than or equal to 10 times lowercase n.
Jeez. Sorry.
Alright, so what's the difference between the first column and the second column? As far as like on your paper, this one is the first column, what's the second column? And so what changes with my conditions? This is a trick question. Nothing. So go ahead and write those same things in the second one while I start writing down your test grade so I can get back to you.
Saturday. I just realized I still have to take the second part of the.
Okay, then I can't get back. Okay, then do you want to stay today and do it, or do you want to do tomorrow?
Tomorrow.
Okay, that's good. Alright, so the whole first section of the requirements is just what your conditions are. The next section is if we're doing a confidence interval, what's our equation? So with means, don't write what I'm writing. This is always your formula for confidence interval. What goes here is whether we're dealing with means or proportions. What goes here is always your what? Test statistic, your Z or T, and this is in general always the standard deviation-ish portion of the equation. So what's going to be before the plus minus part? Because we're dealing with means. What goes here? X bar. Well, for this one, what is our critical value? And so if we use Z, what is this section of our equation? If we are running a test instead, then our test statistic equation is test statistic equals what? X bar divided by, so I'm basically taking this equation and rearranging it. So what's going to go down here? What's the standard deviation portion? Just so that I can keep it all on the same page, I'm going to do this one for T right here. What's going to change in my confidence interval equation for T? So X bar plus or minus, now it's going to be an S over square root n. So same thing here, it's now going to be X bar minus mu over
Yes.
Let's go ahead and tentatively plan for this test to be Tuesday. Just so that, because I don't want to throw it on y'all too late. Alright, one proportion Z. Still, our three requirements are random, normal, independent. What are we checking for random? Random selection, assignment. What's my next condition? This one gets a little bit funny because it matters if I'm doing a confidence interval or a test. In general, I'm checking what for my normal condition for proportions. For normal condition for proportions, in general, I'm checking what is at least what. The what? Success is at least 10. So n times p, but sometimes I have p and sometimes I have p hat. So if it is a confidence interval, that means I do not know my what? P, which means can I use p in my equation? No. So for a confidence interval, it is n times p hat and n times 1 minus p hat. And both of those have to be what? And I know we usually do the written portion, like the in context in words. For this, we're just writing the straightforward part. So do what? So what's it going to be for the test that's different?
It's gonna be P, not P hat.
It's going to be P, not P hat.
No, I mean for our test.
Yes, yes. I'm writing it
Okay.
word for word exactly the way I want your test to look. And then my last condition, this should get really easy because we didn't do much of any changes with this at all. Pretty much always independent 10% condition, exactly what we think it is. So our confidence interval formula, instead of starting with X bar, it now starts with what? P hat. I usually have the decision of Z or T, but because it is proportion, it has to be. And where it was sigma over square root of n or S over square root of n, for proportions, it is and so we're using hats here because there's a confidence interval, which means we are estimating P, which means we do not have it. For test statistic, instead of being X bar minus mu, it is what? And it's technically P naught our claimed value for P. So what's going to go in the denominator? The standard deviation portion, which is,
Square root of P hat times 1 minus P hat.
now is it going to be P hat this time?
No.
It's our P naught. This is our claim value. I'm gonna write it so y'all can actually see it. It'll probably be easier to go to the back, but I'm just gonna keep going for now. Chi-square goodness of fit. So this is where it changes very, very, very slightly. Do we still have randomization? This one, I don't want to even make a big deal about this. If it is goodness of fit, it's always random selection. I don't know if I'm going to make a big deal about that. Of all things to worry about 4 months out from the AP exam, knowing that it can't be random assignment is probably not my biggest issue right now. So if you wrote random selection / assignment on the test, I'm not going to cut off there. Now this is one of the weird ones because instead of calling it normal, we now call it what? Large sample size. Which is still essentially checking the same thing because when we did it for normal for here, we were checking to make sure that our sample sizes were large enough, but success and failures were large enough. Alright, so what am I actually checking for there?
All your expected counts are greater than or equal to 5.
And then my last condition is still exactly the way that it was before. And we do not have a confidence interval equation for chi-squared stuff. And just like I said, that's not something I'm going to try to trick you with on the test. I would give you the same thing of asking you to fill it out. It's just not going to be in this order. They'll just be jumbled up. The columns will be jumbled up. All right, so for test statistic, I'm solving for chi-squared. And what is my equation for chi-squared? What's my equation for chi-squared? Well, I know I've got expected stuff. So what's my equation that uses the word expected? The sum of observed minus expected. But I do what with those? Square that. And I will tell you, I don't know that I've necessarily, you might want to do that because that's a common thing that people forget as far as writing it down on the test. Divided by expected. And I will post this blank sheet so that if anybody wants to practice it without like having to rewrite everything, you're more than welcome to do that. And then I do have degrees of freedom to deal with this. So how do I determine degrees of freedom in goodness of fit? Number of categories minus 1.
You didn't do degrees freedom for sample 2 for means, did you?
No. So this is the first one we dealt with that required the degrees of freedom. Is matched pairs the last column that y'all have?
No, it's on here, revision, that change on the bottom.
I've rearranged this so many times. Oh, I did match pairs on the bottom. I did the bottom of this page.
Yeah.
Let's just go ahead and do it. Does it say define parameters your first thing? Did I not do requirements? It's pretty stupid. Why am I not big about requirements? What is match pairs actually done as? Once you match them, you actually only have a what? One sample, so it ends up being the same as one sample. What is the parameter that we use? What we're dealing with means or proportions if we have matched pair. Means. So we define a parameter of mu of what? Which is the true mean difference. And I'm shorthanding this to be able to write it easy. Define your direction. So if you just write mu1 minus mu2 there, I'm fine with that. Alright, so my confidence interval equation, we just said it ends up being a one sample mean. So this should be really easy. What goes at the before your plus minus? What went before plus minus last time I did one sample for means? But more specific, this is x bar. Choice between z or t ends up being what? We only use z if we know the what?
Sigma.
Would I know sigma of a difference when I was never given differences? And some of my answer keys, if anybody looks at stuff, some of them have stars to try to find z's and t's. I don't care if you do stars or not. And then what goes here? Just like the one we just did, one sample mean. This would now be S, but it is S of divided by, and I don't care if you write N or ND, why? Because the number of the differences we had is still the same as the number of values we had. So I don't care if you write subscript D for N. Alright, so then translating that to here, our test statistic is what? Just like when we did it with one sample for means, it starts with what? But now this is x bar D. What should go here? Some what? Some number? I'm fine if we just put 0 for this test. Why? Why am I being funny about that? Most of the time we use 0, but do we always have to? Technically no. And then divided by what? just like same up here. Now, I shouldn't need to point this out, but in case some of you are just dazing and there's some epiphany that you haven't had in the last 5 months. This is always the same thing that's here. This is always the same thing that's here. So for a test like this where we're writing them one after another, should make things a whole lot easier. And then, so what is my degrees of freedom for match pair? Because I'm dealing with, is that right? I didn't write this one, did I? Right? Is that what somebody was asking about? I was trying to copy this page and I didn't write degrees of freedom for this one. Y'all have a degrees of freedom for this one that I missed, yes? What was this one supposed to be? How many variables are we dealing with? So it is. And so what should our degrees of freedom be here, because it's the same thing? N-1.